Okay, here we go. We're going to go over the extra practice, which was on page 279. You had to do 17 through 25 odd. Okay, the answers are as follows. If you got them all right, great. You're ready for the quiz on Friday. 17 is 6/35, 6 over 35. Number 19 is a mixed number, 4 and 1/8. 21 is 1/3. 23 is really 3 answers, so hope you're listening. Naomi is 138, Luke is 69, and Natalie is 23. And as I tell you always with word problems, what are we talking about? What's the noun? What are we counting? What are we measuring? In this case, it's votes. Okay? And number 25, the answer is half a cup. Now again, I want you to notice these all these numbers are fractions. All the answers are fractions, excuse me, or mixed numbers. There are no improper fractions and no decimal numbers. Okay? So for the quiz, you will need to write mixed numbers and or fractions, whatever the answer needs, except for decimal numbers and improper fractions. All right, let's get started. I think you guys are getting it. Number 17. Again, multiply and write in simplest form. Do not forget to simplify when it's possible. Okay? On the last quiz, a lot of you forgot, and then you wonder why you got it wrong. Okay? But anyways, let's focus on the positive. You can do better. Multiply, numerators times numerator, denominator times denominator. 2 times 3 is 6, 5 times 7 is 35. And you know what I forgot to do? I forgot to see if we can simplify. But as it turns out, we can't, so it's fine. And 6 and 35, you might think, now I can see where you guys are going to go wrong. You might think, oh, 6 times 6 gives you 35. No, my friend. You cannot divide 35 into groups of 6 equally. You're thinking of 36. This is 35. So no, you can't simplify by 6. Okay? Anyways, number 19. Same thing. 3/8 times 11. Change that whole number to a fraction. 3/8 times 11 over 1. Quick check. Nope, I can't simplify. So, numerator times numerator, which is 33. 2 times 11. 8 times 1 is 8. Now see, right here. This is where somebody will stop. Don't stop. You have to change it to a mixed number. This is an improper fraction. Again, nothing wrong with it, but it goes against the definition of a fraction. We're supposed to be less than 1. Okay, it's supposed to be part of a whole. So we're making groups of 8. Denominator, again, look at the denominator. Tells you everything you need to know. Where to start. Groups of 8. It's a division problem. Remember, 33 divided by 8. Dividend, divisor. All right. You're making groups of 8. 8 times 4 gives me 32. I subtract. I'm left with 1. So I can make 4 whole sets of 8, which gives me 32. I have 1 left over, but I'm making sets of 8. And I told you this before. Unless you're simplifying, the denominator will show up again in the answer. Okay? But anyways, that's why that is what it is. 21. 2/5 times 5/6. Quick check. 5 and 5 definitely have a common factor of 1. 2 and 6 have a common factor of 2. I realize I'm going kind of fast, but this is where you should be at. And it's not because I know more math than you, or because I'm older. I have more experience, okay? And you guys can get there, all right? 2 divided by 2 is 1. 5 divided by 5 is 1. 5 divided by 5 is 1. 6 divided by 2 is 3. Numerator times numerator. Denominator times denominator. Easy peasy, people. You can do this. All right. 23. Whew, this is the votes. The table shows the fraction of the votes that each candidate received. If 230 students voted, how many students voted for each candidate? Okay, so we're talking about votes. In total, there are 230 votes. Okay, 3 people ran for office or a position in government, whatever. But we have Naomi. I'm writing her name for a reason. Bear with me. 230 votes times Luke. 230 votes times Natalie. Okay. The reason I wrote the names out, there are 3 answers for this problem. Okay? You have 230 votes. Those votes got split up between these 3 people. Okay? So I'm going to show you the math for just a moment. So out of 230 votes, according to the table, Naomi got 3/5 of the vote. So for every 5 votes, think of it, 3 of them went to Naomi. For every 5 votes, 3 of them went to Naomi, right? Okay. Okay, 3 and 1, you can't simplify, but look, see how this number ends in a 0 and this ends in a 5 in the ones place? That means 5 is a common factor. I can divide by 5. And now see what I meant earlier? When you get big numbers, you could multiply this by 3 and 1 times 5, say, oh, I'm done. But now you have to divide this big old number by 5. For me, it's much easier to divide a smaller number, okay? But you do what's best for you. I've always told you that, guys, okay? Do it your way, whatever works. So out of 23, I can make 4 groups of 5. Then I'm left with 3. I bring down the 0. Hey, there we go. 46. Now, is that right? Did I do something wrong? No, the math is right. Oh, you know what I forgot? It's not 46. It seemed really small. Can you guess what? And I'd like to say I did this on purpose, but I didn't. I totally forgot something. Watch. And somebody might have already caught it. The 3 is still there. So 46 times 3 is 138. That makes more sense. Again, look at this. How did I know that this wasn't right? 46. How did I know that? Why did I say, oh, I made a mistake? 3/5. That's more than half. That's more than half. Half of this would be 115. This is nowhere near that. That's how I know I'm up. It's like, why isn't the answer what I thought it was? Ah, I forgot about the 3. So look at that. Teachable moment for you and for me. For me, slow down. And for you guys, pay attention. So anyways, that's Naomi. What about Luke? Okay, I'm going to have to use the other side. Okay. Luke got 3/10 of the vote. I'm kind of skipping a step there. Out of 23 votes, he got 3/10. So for every 10 votes, he got 3. Now, kind of a bit playing on what I did earlier, I'm looking at this. That's not even half. That's less than half. Half would be 5. 5 votes for every 10. But he got less than that. So it's going to be less than half. We already said half is 115, so it's going to be less than that, I think. If I do the math right, let's find out. Okay, nope, can't simplify. Yes, they both end in 0. I can divide by 10. Right? Now, you're like, wait a minute, whoa. You know what, I could do this in my head, but let me just show you what's going on. This is going to be 23. If they both end in 0, I can kind of cut it out. Or basically divide it by 10, right? What's 23 divided by 1? 23. But let me show you the math anyways. 10 times 2 is 20. If you already know this trick, that's great. $23. And I'm not going to make the same mistake I made last time. It's 23 times 3. 3 times 3 is 9. 3 times 2 is 6. 69 votes for Luke. And Natalie. Out of 203 votes, she got 1 vote out of every 10. Divided by 10. I think you already know why. They both end in 0. Ah, you know, we did this before. So it's going to be 23 over 1 times 1 over 1. 23 times 1 is 3. 23, excuse me. 1 times 1 is that. And when you, this is a division problem, remember this. 23 groups of 1 means you have 23 groups of 1, right? And so there you go. And I forgot to write the word votes. And that is 23. Okay. 25. I think we have space here. I don't think we have to. Let's see, 25. Lee is making chocolate chip cookies, and the recipe calls for 3/4 of a cup of chocolate chips. Okay, let me just draw that real fast. Okay, if you've seen a measuring cup, kind of looks, well, Mine's weird, but that's okay. Again, the goal here is not to be an artist, just to get an idea going. All right, we have a measuring cup for a cup. 3/4. 3/4. That means we're making sets of 4. How do I know that? Because the denominator is 4. 1, 2, 3. That should be equal, but that's okay. 3/4. So if we have this cup and we cut it up into 4 parts, or split it up into 4 parts, or if we drew 3 lines on them equal, it would fill up the first up to the first 3 lines, and this part will be empty. So 3/4 chocolate chips. And let's see, let me read the rest of the problem. If she wants to make 2/3 of the recipe, what fraction of a cup of chocolate chips will she need? Okay, so here's the deal. For a full recipe for this chocolate chip cookies, we need 3/4 of a cup of chocolate chip cookies. 3/4 cup. Let me add the word cup so we know what we're talking about. But this person, Lee, doesn't want to make a full recipe. Maybe the recipe is for 10 cookies, but it's only him. And he just wants to say, you know what? I only need part of it. I only want in the mood for 5 cookies or whatever. So he's going to use part of this, right? He only wants 2/3 of this. So 2/3. 3/4 of the cup. 3 parts out of 4 filled in with chocolate chip cookies. But of this, he only wants to use 2/3. Now every piece, it's like if you cut it up in 3 pieces, 1, 2, 3. 1, 2, 3. 1, 2, 3. And since we're talking about the whole thing, you have to include even the part that you don't have. 1, 2, 3. Okay? Now consider, after doing that, we want 2/3 of this. Yes, even shade in the part that you don't have. But remember what I said earlier? Okay, part to whole. Considering the answer. Originally we had 4 parts. But now that we cut each part into 3, how much do we have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 parts. Now, originally we just had these 3 lines. This one's empty, so we're not going to count this. And for what we have, we cut that. We're going to ignore this. This doesn't count. We just want this. We just want this part. How many parts are there? 1, 2, 3, 4, 5, 6. 6 12ths. But what's that? Can we simplify this? Yes, we can. Now I can divide by 2, right? But then I'll have to keep dividing by 2 until I get to the final answer. I can divide by 3. But I know that the GCF, greatest common factor for both of these, is 6. It becomes 1/2, right? So it is 1/2 a cup of cookies. And that's it. That's number 25.